Okay, here we go. Question 3 here. So you've got to be careful with these questions because there's a lot of words going on here. So a company produces a particular type of light globe called shiny. The company claims that the lifetime of these is normally distributed with a mean of 200 weeks. All right, so this is the company's claim. It is known that the standard deviation of the lifetime of shiny globes is 10 weeks. All right, so that's the whole population. Now, customers have complained that shiny globes were lasting less than the claimed 200 weeks. It was decided to investigate. A random sample of 36 was tested and found that the mean lifetime in the sample was 195 weeks. So use this information that the probability of Z being between negative 1.96 and 1.96 is 0.95, and that the probability of Z being between negative 3 and 3 is 0.9973 to answer the following. Okay. So a lot of words, and you can get confused if you're not careful. So write down the null and alternate hypotheses for the one-tailed test. All right. So the null hypothesis. So the null hypothesis is that the mean is what it is claimed to be at 200 weeks. The alternative hypothesis is that the mean is not. However, it's a little bit more complicated than that. One, we've got a one-tailed test, so we're only looking at one end of the normal distribution, not both. And the other key thing that you've got here is less than. So the customers are saying that it's less than. So the alternative hypothesis then is that the mean is less than the claimed 200 hours. All right, so a couple of things to watch there. All right, that it's one tail, not both. So you can't just say it's not equal to. You've got to make a decision. Is it more or is it less? And the information tells us less. All right. That's enough on that one. Okay, determining the p-value. All right, so this is quite interesting. Okay, so this determining the p-value, you need to use this. All right, so p-value is the probability that x bar is less than the mean, sample mean, given that it's below the mean. So that then is the probability of Z being less than sample mean minus population mean over sample standard deviation. All right, so you would need to have remembered that to be able to, oops, that's not what I want. You will have, as I said, needed to remember that. There we go. All right, so what do we know? All right, we know that the expectation value of x is 200. All right, that's our population mean. Our standard deviation of X is, well, population standard deviation is 10 weeks, but we've got a sample of 36. And so our sample standard deviation, distribution sample mean, so this is what we're going, the sample mean is the mean, all right? The variance is standard deviation squared over the number in our sample. So square root that, of course, to get the mean, the standard deviation. So that is then 10 over 36, which is not 10 over 36, square root of 36, which is 10 over 6, which is 5 over 3. All right, so our p-value then. All right, they've got to squeeze this in. Now, they haven't really, in my opinion, left us quite enough room here, and there's a few questions where that may be the case. All right, so what we're saying is that the sample less than 195, where did I get the 195 from here? All right, so we're doing the p-value about this, so 195, given that the mean is 200. All right, so that is the probability then that Z, and that's where we're using this, is less than 195 minus 200 divided by 5/3. And so that is Z, is less than -5 times, because if we're dividing by a fraction, multiply and flip. So that then is, if I come up here, that P is the probability that Z happens to be less than -3. All right, now we've got something to do with -3 up here. That's this one here. It tells us that the probability that it's between -3 and 3 is this, 0.9973. And so on our thing here, -3 to 3, that in there is what is the value that we're given. That's what I've just shaded. Now, of course, we want this little bit down there, so that little bit is what's left over. So what's left over, of course, it's all out of 1, so it's 1 minus 0.9973. But of course, that's shared. What's left over is shared equally, because the normal distribution is symmetrical, so it's shared equally. All right, so this is 0.0027 over 2, which happens to be 0.100135. All right. Now, it says correct to 3 decimal places. I've got more than 3 decimal places there, so it's got to be 1, 2, 3 decimal places. All right, 2 marks there. It's a bit tricky to get that squeezed in. but there we go. That's how we do it. All right. Second part. What should the company be told if the test was carried out at the 1% level of significance? Okay, 1%. 1% is 0.01. Now we've got a p-value of way less than that, factor of 10 in fact, less than that. And so the p-value is less than the 1%, 0.01. So what we should do is reject the null hypothesis. All right, because our p-value is testing our null hypothesis. So it's testing the claimed, the 195, against the null hypothesis. And so we've got a low p-value. So that tells us that we should reject the null hypothesis. And so the mean then is in fact, according to this p-value, less than the claimed 200, but that's a bit extra. You didn't actually need that, but this is really all you need. So you need to say reject, but you also need to refer to the p-value, because the p-value is the reason that you use to reject. All right, the next one. So the company decided to produce a new type of light globe called Globe Plus. Find a 95% confidence interval for the mean lifetime. All right, so what do we got? If a random sample of 25 globes is tested, so n is 25, the sample mean, x bar, is found to be 250 weeks, and the standard deviation of the population, so that's sigma, is 10. All right, so we are looking for the confidence interval. So we go to our special maths. Here's our confidence interval. All right, x bar minus z s over n, x bar plus z s over n. So we know what we've got x bar. We've got our standard deviation. We've got n, our sample size. We just need to use the z. Now, in this particular question, they give us some information about the z, because it says the 95% confidence interval. So remember the 68, 95, 99.7 rule of thumb. And so when we go back up here, that's where this other bit here, this 0.95 comes into 95%. So the z that we're going to use is not the rule of thumb Z2 standard deviations, but the one that we're actually given here, the 1.96. All right, so what have we got then? So we've got our confidence interval 250 minus Z, which was 1.96, I think, 1.96. 1.96 times the standard deviation over the square root of our sample, and then 250 plus 1.96 times 10 over, again, square root of 25. And there is our interval. And so now we've got to go ahead and figure all of that out. So that's 250 minus 1.96 times square root of 25 is 5, goes into 10 twice, All right, and 2 times 1.96, whoops, minus 2 times 1.96. You can work this out to the side if you want, but it's 3.92. 250 plus 3.92. All right, and so you then need to do that. So that's 246.08, and then 253.92 for our 95% confidence interval for this. All right, so common error that was noted in the examiner's reporter was the error for Z. Okay, so again, the rule of thumb for 1, 2, 3 standard deviation is 68, 95, 99.7. All right, however, because you are given information about the confidence interval and what the Z is, for that confidence interval, you need to use the Z that you are given. All right, so there is question 3.